Hello everyone, welcome back to watch my video. This one is chapter 1.4 trigonometry using definitions of trig functions. So last class we have learned about the 6 trig functions, and we will use it a lot in the following lectures. So let's do a little bit review. Last class we have learned if I have a point and I can find the distance between the point and the vertex. And then we can, if we have the point x comma y, and then I can find the r. R equals square root of x squared plus y squared. If I have this information, I can find the signs. So I say sine theta equals y over r. And it's reciprocal. We can write vertically. So its reciprocal is cosecant. Cosecant is r over y. That's a reciprocal of sine. That means, they are couples of each other because they are reciprocals of each other. And next couple, they are cosine theta and secant theta. Why I'm saying something and writing something different. Okay, cosine theta equals x over r. So its couple, its reciprocal is r over x. And the next couple, they are tangent theta, y over x. Cotangent theta is x over y. So let's do the review. Here, if I have the sine theta, I know its reciprocal is 1 over cosecant theta because sine, cosecant, they are reciprocal. If I have cosecant theta, that's 1 over sine theta. If I have cosine theta, its reciprocal is secant theta. It's 1 over secant theta. And secant theta equals 1 over cosine theta. Next couple, they are tangent and cotangent. Tangent theta equals 1 over cotangent. Cotangent equals 1 over tangent theta. All right, let's use these 6 identities to solve the following 2 examples. Example 1, given secant theta equals 5 over 3, find cosine theta. Secant theta, cosine theta, they are reciprocal to each other. That means if I have the cosine theta, that is 1 over secant theta. That means I just need to swap the top and bottom. Then I can find the cosine. So cosine is 3 over 5. Next one, given cosecant theta equals negative square root of 2 over 2, find sine theta. Cosecant, sine theta, they are reciprocal of each other. That means sine theta equals 1 over cosecant theta. Then I just need to write the fraction upside down, but I need to keep the negative sign with it because reciprocal will not change the value, positive or negative. So bring the 2 to the top, bring the square root of 2 to the bottom. Can I keep this fraction? I shouldn't do this because this is the bottom has a square root. So I need to rationalize this expression. How to rationalize the fraction? I should multiply the top and bottom by the square root of 2. So if the bottom is something else, square root of, for example, ABC, if I want to rationalize the bottom, top and bottom multiplied by square root of A, then I can get rid of the square root at the bottom. So what is the next step? Top and multiply by the top. This multiplied by the top, and bottom multiplied by the bottom. We have 2 square root of 2. The bottom is square root of 2 times square root of 2. Is that square root of 2 squared? square root, squared canceled. We're having 2 square root 2 over 2. 2 canceled, and we're having square root of negative square root of 2. So this is a solution. All right, let's see. Next part. So this part, we want to decide all the 6 trig functions. They are positive or negative in the 4 quadrants. So let's move to the white space here. If I have the xy plane, I can divide it into 4 parts. First, we say this is quadrant 1. Quadrant 1, because we are rotating counterclockwise. So here is quadrant 2. This one is quadrant 3. Last one is quadrant 4. So the 6 trig functions in these 4 sections, what are their signs? They are positive or negative. So in the first quadrant, so any point in the first quadrant, I'm having all the x value positive, all the y value positive. In the second quadrant, all the x, they are negative because any point here, they are negative. And y's value, they are positive. Because they are above the x-axis. So any point here, they are positive y's value. How about quadrant 3? Quadrant 3, all the x and the y's value, they are negative. And last quadrant, x value, they are positive, and y's value negative. Because if I have a point here, x value positive, for example, positive 1, and y's value is negative 2. So positive x, negative y. All right, if I have all of these information, and how about my signs? So for example, I have a theta in the first quadrant. This is theta, and in the first quadrant, sine theta equals y over r. Y is positive, and r, they are always positive because r represents the distance from the point to the origin. So r is always positive. I have positive. And cosine theta, that is x over r. So x is positive, while r is positive. I have positive ratio because, for example, I have a so I have a point 2, 3 in the first quadrant. So x is positive, y is positive. So we will see the ratio between y over r, x over r, they are all positive. How about tangent? Tangent theta equals y over x. X and y, they're all positive in the first quadrant, is positive. Or you just put more steps, you have positive or over positive. It is positive. And how about their reciprocals? So how about their couples? The sines couple is cosecant. Must be positive because you flip this upside down. Find the reciprocal of this positive number is positive. How about the second theta of second theta is positive because reciprocal of cosine, and cotangent theta is positive too, reciprocal of tangent. So if I have all of this information, I can decide the sign of the 6 trig functions, but it takes me too much time. So here there is a trick. So help you to memorize positive or negative of these 6 trig functions. Here is x-axis, here is y-axis. And we say this is first quadrant, we say A, S, T, C. A represents all. We say all. So all students take calculus Okay. So A, S, T, C. So A, S, T, C. What's the meaning of A? A represents all 6 functions. They are positive in the first quadrant. And S represents sign. So sign is positive in the second quadrant. So for example, any point here or any angle in the second quadrant, so their sign's value is positive. So S represents sign and sign positive. And T represents tangent positive in the third quadrant because tangent equals y over x. If x and y, they are all negative in the third quadrant, so tangent is positive. And C represents cosine. Cosine positive in the fourth quadrant. All right, how about the reciprocals? A means everybody. All 6 trig functions, they are all positive. Sine and its reciprocal, they have the same sign. So sine's reciprocal is cosecant, but you don't need to write it down here too much things here. You need to memorize sine's reciprocal is cosecant. In the second quadrant, it is positive. How about the reciprocal of tangent? Cotangent. So in the third quadrant, cotangent is also positive. So not too much information. How about the fourth quadrant, positive? Not only the cosine, but also its reciprocal secant theta. In the third quadrant, that is a positive. So ASTC, that is counterclockwise rotation. ASTC, all students take calculus. All right, here is a table. I don't suggest you to take a lot of time to memorize this, but I suggest you to do the ASTC. All right, let's see the example 3. Determine the sign of the trigonometry functions that are of an angle in standard position with the given measure. Okay, let's see. Plot the point on the XY plane. Excuse me. This is the XY plane. Where is the angle 87? In the first, second, or third, or fourth quadrant? First, because if I have a point here, so the angle is 90 degrees, but this point is not the 90, less than 90 in the first quadrant. So in the first quadrant, this is theta. So how about sine 87 degrees? Is positive or negative? So positive, remember that ASTC in the first quadrant, everybody positive. That means sine is positive, is reciprocal, is couple cosecant. Positive, and cosine positive is reciprocal positive. So tangent, let's ignore the degree. Positive, cotangent, positive. They are all positive. How about number B? Where is the degree 300? Let's find the 300. So if I wrote it this way, okay, 300 is here in the fourth quadrant. So let's put some information here. Let's erase this. So let's put A, S, T, C. All students take calculus. So in the third quadrant, only the cosine and its reciprocal is positive. Let's highlight the cosine C. All right, that means when I'm doing finding the sine 300, I can ignore the degree, the angle maybe. So sine in the fourth quadrant, negative, and cosine is positive in the first quadrant. How about tangent? Tangent in the first quadrant, negative. How about their reciprocals? Cosecant, negative. And secant, positive, because they have the same sign. How about cotangent? Cotangent, negative. Okay, let's see. Next angle is a negative angle. That's negative 200. So we need to do the clockwise rotation from the initial this way. So let's do the rotation. Okay, this is negative 180 degree, and continue to rotate. All right. So here, negative 200 is in the second quadrant. So let's put ASTC here, ASTC. So in the second quadrant, sign is positive. So we say sine to negative 200 degree is positive, and cosine positive or negative in the second quadrant. It doesn't have a C, it only has S. That means cosine is negative. How about the tangent? Tangent in the second quadrant is also negative because we only have the S in the second quadrant. How about their reciprocals? So the reciprocal of sine is secant. Secant is positive. They have same sign. And secant, negative, cosecant, negative. So we decide the sign of the 6 trig functions. Okay, let's see example 4. Do we need space? Let's see. Let's try. So number 4, identify the quadrant of the theta. So it gave us some information. Okay, where is the angle theta? First, second, third, or fourth quadrant? So we put ASTC here, ASTC. So first information is if the sine theta is greater than 0, sine is positive. I will check, maybe use the the blue to check where the sine is positive. I know everybody positive in the first quadrant, and sine theta positive also could be second quadrant. The second information is tangent theta is negative. So tangent positive is in the first quadrant and the third quadrant. If tangent negative or less than 0, I will highlight. So I will highlight this quadrant and this quadrant because these two quadrants make the tangent negative. How about the theta satisfy these two conditions? Satisfy the first condition and the second satisfy the second condition. That means my theta must be in the second quadrant. So it satisfied both conditions. So the theta is in quadrant 2. All right, let's see second example. I will draw the xy plane and then find my ASTC in the fourth quadrant. So cosine theta is less than 0. Which two quadrants make the cosine negative? Satisfy the first condition. So cosine negative, I'm having the second quadrant and third quadrant because I know that here and here make the cosine positive. How about second condition? So let's highlight this. Second theta less than 0. So in my ASTC, the S is sine, it's not a secant. So if I want to decide the secant positive or negative, it's related to cosine, it's reciprocal. So secant theta and cosine theta, they are related because secant theta is negative, that also means cosine theta is negative. So where is the cosine theta negative? Let's use this and this, or also means secant theta negative. Oh, so the theta is in quadrant 2 or quadrant 3, because satisfied these two conditions inside quadrant 2 and or quadrant 3. All right, let's look at about the range of the trigonometric function. So what is the meaning of the range? Range in the college algebra we have learned, that's all about the y's value. So we have learned if I have a function f of x equals something, and now if I have f of x equals sine x, oh, that means here f represents the functions, the name of the function, and now I'm having the function named the sine, and they all have the same input. Oh, the sine, cosine, tangent, cotangent, secant, cosecant, they are all functions. So the range of the function, that means I want to find the value of this part. So what is sine x? What is the cosine x? What is the tangent, cotangent? So I want to evaluate what are these. These are the functions value. And later we talked about the domain. Domain means input, x value. All right. In this table, for the sine and cosine, the range, the y's value is between -1 and 1. -1, 1, they are included. So the sine and cosine theta is greater than -1, less than or equal to 1. And tangent theta, cotangent theta, so the value, the range value is -infinity to infinity. There's no restriction. For the secant theta, cosecant theta, that's y's value is so it's between -infinity to -1, union -1 to infinity. All right, let's see some identities. The Pythagorean identities. So first one, they are sine theta squared plus cosine theta squared equals 1. And tangent theta squared plus 1 equals secant theta squared. Last Pythagorean identity is 1 plus cotangent theta squared equals cosecant theta squared. Reciprocal identity, the second column. So we have reviewed this before. Cosecant equals 1 over sine theta. Secant theta equals 1 over cosine theta. Cotangent theta equals 1 over tangent theta. Last part is quotient identities. Tangent theta equals sine over cosine. Cotangent equals cosine over sine. So you better take some time to memorize these identities. They're super helpful. And also in the following lectures, we will repeat learning all of these identities. Okay, let's see example 5. So let's use the identities. Let's use the identities to find the sine theta and tangent theta. So this one, I'd better to have more space. It's too small. Okay, I think it's good enough. All right, it gives us some information. Cosine theta equals -3 over 5. Theta is in quadrant 2. When I see this information, I like to draw image because image can help me solve the question easily or more accurately. So in the second quadrant is here. All right. So for the x value and y's value in the second quadrant, I remember that all the x in the second quadrant is negative. All the y's value, they are positive. So x is negative, y is positive. Maybe I will use it later. All right, let's find the sine theta. For the identity, Pythagorean identity, I have learned that sine theta squared plus cosine theta squared equals 1. So the cosine is given. So sine theta squared plus cosine theta is given. So the meaning of cosine theta squared, this, we can move the squared outside. That means what is cosine? -3/5. All of them squared. So this one equals cosine theta squared, because in trigonometry, even I know that the squared means cosine all of them squared, but we put the squared at the corner, upper corner of the cosine. All right, let's put the information in the equation. We have -3/5 squared equals 1. And then we need to solve for the sine theta. Sine theta squared, so plus negative squared is positive, 9/25 equals 1. And subtract 9/5 both sides. 9/25. So sine theta squared equals 1 minus 9/25. That is 16/25. Any question? You know how to do the subtraction? So if, let's slow down maybe a little bit. So if I do the subtraction between the integer and the fraction, I must convert both number to be the fraction. So 1, I convert both number to have the bottom 25. That means the 1 multiplied by 25/25 minus 9/25. So the sine theta squared equals 25/25 minus 9/25. It is 16/25. And then we have sine theta squared equals 16 divided by 25. And then I take the square root of both sides. So you take the square root of unknown information, I must have positive or negative sign. So the sign maybe sine theta maybe equals positive or negative 4/5, because I know that take the square root of a fraction, take the top one, take the square root of the bottom one. Then you simplify that, you got 4/5. So can I keep two solutions for the sine theta? I cannot, because here it give us that theta is in the second quadrant. In the second quadrant, sine is positive or negative? A, S, T, C. Sine is positive in the second quadrant. That means I can only keep this positive solution 4/5. All right, how about the tangent theta? So the tangent, no, so it's okay if I use red. So tangent theta, by the quotient identities, so you come here to see the quotient identities. What is that? The sine over cosine. So let's do this. Sine theta over cosine theta. Sine theta is positive 4/5. Cosine theta equals -3/5. All right, the division between two fractions, we do the keep the top fraction 4/5, and then change the long division line to be multiplication. Flip the bottom fraction 5/3. Then do the multiplication. We have negative 5 canceled. 4/3. This is a solution. This is solution for the sine theta. So we solved this one. But I suggest you to use the second method. I think the second method is easier. So let's copy the question. Can I copy the question? It's not copied. Okay. Okay, let's do the new area and continue to use the second method. So let's do this. Way 2. So the given information is cosine theta equals what? Equals -3/5. And theta is in the quadrant 2. So this symbol that represent is belong to or inside of some intervals. Looking for sine theta and tangent theta. So use the old method we have learned before. So if I want to find the sine theta, you remember that's y/r, and tangent theta is y/x. If I can find the y/x informations, I can find the sine tangent. So let's use the old method we have learned. Here, it gave us the information theta is in the second quadrant. So normally, we will always sketch something in the second quadrant because it's the given information. And then the cosine theta is, so cosine theta equals x/r. And it is given that's -3/5. So let me ask you, can r be negative? No, r is always positive. That's the distance. So r is 5. From the given information, I can tell that r is 5. How about the x? X, -3. So x is -3. How about the y? So we have learned that there is a formula r equals square root of x squared plus y squared. And r and x, they are given. I'm looking for the y. I square both sides. R squared equals x squared plus y squared. So isolate the y. Y equals square root of x, y squared minus, and why I'm having this, r squared minus x squared. But I must have a positive or negative sign here because I want to isolate the y. That is the variable unknown information. So let's find the y by the formula. So let me ask you, in the second quadrant, y is positive or negative? Positive. In the second quadrant, we have x negative, y is positive. So I'm only keeping the positive sign here later. All right, so let's solve the y. Y equals square root of r squared. So r is 5. 5 squared minus -3 squared. Let's do the simplification. 25 minus 9. So I'm having square root of 16, that is 4. I didn't put a positive or negative sign here because I know that this is a positive y. But later in the other quadrant, like quadrant 3, quadrant 4, I must have a negative y. All right, we have the x, y, r's value. How about my sine theta? sine theta equals, I think it's a little bit messy. Sine theta equals y over r. Y is positive 4. R is positive 5. How about tangent theta? Tangent theta equals y over x. Y is, where is my y? 4. X equals negative 3. That's negative 4 over 3. All right. We have the same solution like the previous one. So which one do you like? You can pick one you like. All right, let's see next example. I think we need more space. Okay, so number 6. If I'm using the second method we mentioned in previous example, so to solve the sine theta and secant theta. Let's see, let's find the angle in my quadrant 1, 2, 3, 4. So theta is in quadrant 3. Oh, it's here in the third quadrant. And tangent is given. Tangent equals 3 over 4. And find sine theta and secant theta. All right, I know that sine equals y over r. And secant, that's a reciprocal of cosine. So that is r over x. Let's find the x, y, and r. So tangent theta equals 3 over 4. I know that we have learned tangent also equals y over x. So let me ask you, can I say, so it's a question mark here. Can I say y equals 3 and let's the x equals 4? No, because in the third quadrant, every point, the x is negative, y is negative. So y over x is positive because both of them negative. That means I must put a negative sign for 3 and 4. That's the value for the x and y. So how about the r? So r equals square root of x squared plus y squared. Put the x and y inside. So r equals negative 3 squared plus negative 4 squared. So do the simplification, r equals 5. R cannot be negative, so r is always positive. Now I have the x, y, r. Can you find the sine theta? Sine theta equals y divided by r. So y is negative 3, r is 5. So it's negative 3 over 5. Yes, sine in the in the third quadrant is negative. It is negative. How about the second? Secant theta equals r over x. What is r? 5. What is the x? Negative 4. So we have negative 4 over, negative 5 over 4. We solved this question. It's really fast. All right, we have 2 more questions left. Let's see. So first, let's see, where is the theta? It didn't give us any information. The theta is in the first, second, or third, or fourth quadrant. We need to figure out by ourselves. So we can graph it, the xy plane. So secant is negative. Secant is the reciprocal of cosine. Also means cosine negative. If cosine negative, let's put ASTC here, ASTC, all positive in first, second quadrant. Sine is positive in the second quadrant. Tangent positive in the third cosine is positive in the fourth quadrant. All right, so cosine negative is in the second and third. Let's highlight this. Because second is the reciprocal of cosine. That means I need to find cosine negative. Next information, sine theta is positive. Sine positive is everything positive in the first quadrant and sine positive in the second quadrant. That means I need to satisfy both conditions. So theta is in quadrant 2. All right, we got this information. We can find remaining trig functions of theta. So here we have secant theta equals negative 12. Also, secant theta equals r over x, reciprocal of cosine. Okay, can you convert 1 over 12 to be a fraction like the right side? Yes, I can, because I know that negative 12 equals 12 over 1. And I can bring the negative here or to the bottom. I know that r never equals negative. So r could be 12. X equals negative 1. In the second quadrant, x always be negative. So I can assume that x equals negative 1, r equals 12. How about the x? How about y? So y equals positive or negative square root of x, r squared minus x squared. Put the x and r inside. If you don't know how I get this, so you must know that r squared, r equals square root of x squared minus plus y squared. So if I'm looking for the y squared both sides, r squared equals x squared plus y squared. Isolate the y minus x squared both sides. Then take the square root of both sides. I can get y equals this. I cannot decide positive or negative. Now I need to go back to see the theta in the second quadrant, y positive. That means my y have no negative sign. Square root r squared is 12 squared minus x squared negative 1 squared. Let's continue to find the y's value. The square root of 144 minus 1. That is square root of 143. Now let's find sine theta. Sine theta equals y over r. So what is the y? Y is square root of 143 over 12. All right, cosine theta. So I don't think I need to do the x over r, because I know that the cosine is reciprocal of cosecant is given at the beginning of the question. So if I input the data, it's okay. Negative 1 over 12 is negative 1 over 12. And tangent theta equals, this is a t. It's not good looking. So tangent theta equals y over x. What is the y? Square root of 143 over the x negative 1. So I have square root of 143. How about their reciprocals? So sine's reciprocal, cosecant theta, is flip this one. I have 12 over 143. And rationalize this. 12 times equals 12 times 143 over 143. Because top and bottom multiply by square root of 143. How about the second theta? So do the reciprocal. I think it's given at the beginning of the question, -12. How about cotangent theta? Cotangent theta is, I think I missed something here. Here is negative. I must keep the negative sign. Okay, that is -1 over square root of 143. Do the rationalization. I'm having negative square root of 143 over 143. All right, let me see if yes, everything correct. Let's move on to see next part. So the last question is example 8. So sine theta equals -1. Find the remaining trig functions of theta. All right, where is the theta? It didn't give us too much information. So sine theta equals -1. What is sine theta? Sine theta equals y over r. So it gave us the information is -1 over, at -1. I know that r is always be a positive number. So if I want to convert the -1 to be a fraction, I can make a 1 over 1. And then r is always positive. I can put the negative on the top. Oh, that means y equals -1. R equals +1. Can you find the x? It's an interesting question. So you see y is -1. R is 1. Can you graph it? So when the y equals -1 is here. And then the distance between this point to here is r. Oh, so the point is here. And also you can find it's by the formula x equals positive or negative square root of r squared minus y squared. So if you want to ask me, how did I find this formula? I got this from r squared, r equals square root of x squared plus y squared, and isolate this x. Okay, so I put all the information in it. X equals positive or negative square root of r squared, 1 squared, minus -1 squared. Okay, x equals square root of positive or negative 0. That is 0. So I have the x value 0, y equals -1. It is the point here. So we have 0, -1. All right, we have a lot of information, x, y, and r. Can we go and find the trig functions? Yes, we can. Let's see. So sine is given. Sine theta is given is -1. So how about cosine theta? Is the x over r. X is 0. R is 1. It is 0. How about tangent? Tangent equals y over x. Y is -1. And what is x? Oh, x is 0. That means undefined, because the bottom cannot be 0. How about their reciprocals? reciprocal of sine is cosecant. Cosecant theta is also -1, reciprocal of -1. And the second theta, so r over x, 1 over 0, undefined. How about cotangent theta? Cotangent theta x over x over y. 0 over -1, it is 0. All right, we solved the 6 trig functions. We solved all the questions in chapter 1.4. If you have any question, please let me know. Have a good day. See you next video. Bye.